Hello, it's me, Mr. Burkhart, here with another video. Today I'm going to explain the average speed lab assignment. So here we are in the modules, week 2, assignment number 4, lag time. If we open that up, we will see slowly over a period of weeks, things load. It's still working on it, but I'll go ahead and talk. So right here, this is where you have clicked on the link to watch the video that I'm making right now. And here there's a video of a slow motion hockey puck. And then this is a high speed ping pong ball. Anyways, so what we're going to do today is going to learn about average speed and then do a little lab activity concerning average speed. So I'm going to switch over to here. Here's my average speed lecture. You can find this slideshow here on the Canvas, link to slideshow used in video. All right, so first, before we really talk about average speed, we have to talk about a couple of other concepts. What is distance? What is displacement? This is kind of where we start in physics a lot of times. If you click on this picture here of the little red car, it'll take you to a YouTube video created by somebody else who did a pretty good job of explaining. So if you'd like to watch a 2-minute, 42-second video on the topic, in addition to the one that I'm making, feel free. That's just extra information. So basically, let's say we start at point A and we wander around, right, and we wind up at point B. So the distance that we travel is actually just the running total of the meters or feet that we travel. And like your odometer reading in your car. And the odometer doesn't care which way the car is pointing. When you're driving the car, the odometer reading just click, 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 just collects the miles. Displacement is the change in your position from a starting point to an ending point. So if we traveled along the red line, our distance and displacement would be the same amount. But if we traveled along the dotted blue line, our distance and displacement would be quite different amounts. Distance being this running total, displacement doesn't care about where we've been. Displacement just wants to know what the difference is from where we started to where we ended up. Both of these things are measured in feet or meters or kilometers or miles. Normally, when I teach this class, I pretty much just use centimeters and meters. Distance is just the amount only, and a thing that's just an amount only in physics is called a scalar thing. So there's a lot of different things that are scalars. Any of the things that only have an amount only would be scalars, like mass and time. Displacement has a direction. So you can see the direction of this displacement would be, maybe if this were a compass, this would be east and south, so it'd be southeast. It would have a direction. And so things that have an amount and a direction are vector things. So displacement is going to be our first vector thing. So we need to understand the concept of distance and displacement so we can really talk about our first real topic, which is speed and velocity, mostly velocity. Again, here's a video by the same guy who's made a pretty decent 5-minute video on speed and velocity. So speed is basically how fast you're going. You probably know that. Whereas velocity is kind of the same thing as speed, and a lot of times people will use them interchangeably, but basically velocity, or more correctly, average velocity, is the rate that your position changes in an amount of time. And so our formula would be, this really should be just a little lowercase v. So the College Board, if you're watching this video in the college class, they like to use X for displacement. I don't know why, I guess just to confuse people. But normal people would use D for displacement. So the change, since this is the same thing, the change in displacement over the change in time is how fast is your average velocity. And they're both measured in feet per second, meters per second, kilometers per hour, meters per hour, miles per hour. Notice there's always a distance type of thing over a time type thing. Speed is an amount only. It's the scalar thing. Velocity is the vector thing that has a direction. So here's a little picture that shows you the difference. You have 2 red slug bugs. They both have a speed of 25, but they have different velocities because one's going left and one's going right. So we're going to call left negative and right positive. They have the same amount of speed, but they have different velocities because they're pointed in different directions. And you can also a way to see, here is a position graph. We can see this person has walked from 1 to 3. They walked 2 meters. Then they just stood there. And then they walked back from 3 to 0. So that's another 3. So their distance would be 2 plus 3 is 5 meters. But the change in their displacement would be -1 meters. Right? They started at 1 and wound up at 0. And the speed here, or the velocity, this would be a positive velocity because it's got a positive slope. This would be a 0 velocity because it's not moving, and this would be a negative velocity because it's got a negative slope. I'll talk more about how to find velocity from a graph on a different day. I think that's cramming too much into this activity. But we should recognize that this is showing how the rate that a thing is changing its position, right? It changed it to 2 meters in 4 seconds-ish, and then it changed it by 3 meters in 3 seconds. There's the 3 meters, there's the 3 seconds. So that's what a velocity is. So in today's activity, so that's just some background information. Whoops, wrong place. When you watch the video, you can take some notes, and this is kind of like a pre-lab activity is to take some notes here on this CAMI document. Define these words in your own words. And then what you're going to do is you're going to find some sort of measuring tool, wrong side, or other creative method for measuring distance. So you might have a tape measure, you might have a ruler, you might just use your feet, and could use some sort of phone or watch or something else for measure, or just count battleships, 1 battleship, 2 battleship. Find a flat spot that's 10 feet long, try to, get as close to 10 feet as possible, time how long it takes you to walk 10 feet, and repeat that. And then we're going to, I changed my mind about this, record in the lab report. So calculate your average speed. Just go outside and find a place and try to figure out what your average walking speed is in meters per second or feet per second. So that's part 1 for the lab here. Here it is. And show your work. And then in part 2, you're going to watch the hockey puck video, which is here. And we'll watch this. It's just a really short little video somebody made. Whee! So what I want you to do is figure out how fast that hockey puck is going. So they give you some information regarding its distance and its time. How fast is that hockey puck going? So figure that out and explain to me, record your answer in the yellow box, and then explain to me in the big yellow box how you did it. And then for part 3, it's basically the same thing, except now we are going to watch a pink boom. How fast was it going? Wow, I don't know. How would you figure that out? Boom. Okay. So I'm going to make a companion video with a hint for the ping pong ball. I'll show you a way you might do that. So in order to write up your lab report, of course, click text box, and then click in here, text box, I don't know. There we go. And then you can, there it is. Now we can write. It's lag, there you go. So you write in there. If I'd asked you to make a graph, you probably could use some of these other tools to make a graph, but I don't think we're doing any graphing today. I want to get rid of that whole thing. I don't know if I can. Okay. Well, and then don't forget to submit. This is the teacher view. I don't have a submit button. Somewhere around here where the save button is, there's a submit button. So it's going to bug me if this is here, so I'm going to get rid of that. All right. And that, I think, about wraps it up. Thank you.